See, yeah, we will just start this energy conservation in HVAC system. So before going into this, I just want to give you a brief introduction. Let's understand the terminology. What is conservation? Conservation is nothing but preservation and protection. Okay, so preservation and protection. See, nowadays everybody is jumping and saying energy saving, global warming, this, that, and all. So everybody is focusing on the saving the energy, conservation of the energy. All that is now has become a trend. See, I'm just taking you to look at our old lifestyle of us. See, we had a beautiful houses. If you go to villages, even now it is there. The house will be built in the middle of the open ground and facing a one particular direction where they get the nice air, nice light, without heat. All that was our practice of living style. Now, just imagine, because of this metro, because of this urban development, people started migrating to one small area and trying to be there in a very in a very cramped way. That it resulted in many ways. We need to construct the house touching each other, no space between the house, no ventilation, no lighting, nothing. Only you have the four walls and the ceiling to stay. But that is the condition of the city. If you go to our Chennai, Georgetown, it's a old city, you can never be lights off. Lights should always be on because that is the kind of a houses there in Georgetown. Similarly, there are many places. Now, why is this sad situation? See, we are not trying to, why this conservation, why this saving energy, all that has come to a picture. This is not conservation of energy alone. This is the rectification of the mistake what we made in the past. This is again, I'm telling you, we are trying now we are working out all this energy conservation is a rectifications of the faults what we made in the past. The living style, the city plan, the house urbanization, this the house construction methodology, the thick population within the small square kilometer of the area. So everybody wants to be living in urban. So all this changes, all this wrong plans. Now we are thinking of energy conservation. Otherwise, the things were there in place very good when we look at the life of our forefathers. So, what I'm trying to say, when we talk about the energy conservation, let's put the axe onto the root. So, we engineers, the future engineers, have to have the conscious, have to have the sense of where the energy can be saved. See, charity starts from home. Similarly, this conscious of saving energy or the conscious of conserving the energy should start from the home. So let's look at few points quickly before getting into the main subject. I want to tell you a few things to start our conservation from the home. See, as I told you, let's put the axe onto the root instead of beating around the bush. See, first, let's adjust our life, day-to-day life. See, when I say adjust the life, day-to-day life means what I'm trying to tell you. See, we have to have the conscious mind to put off the lights or fans or AC when it is not in use. This we have to have that conscious in our mind. So we'll have to adjust our life day-to-day behavior. They replace your lights and bulbs. So still there are places where the energy consumption more lights and fixtures are there. So that has to be adjusted. They replace your then we always we watch TV or we use computer. We just put it on a sleeping mode and we think that the energy won't be wasted. I tell you, there is a load called phantom load, which means when the TV or laptop or any other gadgets are in a sleeping mode, still it consumes the power. This power is almost 1/10 of the total load of the home. And again, install the point number 4, what I'm trying to tell you, install a programmable or smart thermostat where your AC or any components is being controlled by this thermostat. Then again, point number 5, purchase the energy efficient appliances, because the 13% of the house appliances are consuming 13% power is being consumed by the household appliances. So we need to have the energy efficient system. Again, this is giving a lower than the conventional system of 9 to 25% energy being saved by having the energy efficient appliances. Then point number 7, reduce the reduce your water heating, because nowadays the instant water heater has come. So instead of using the tank, we will have to try to use the tankless water heater, where you heat the water and you don't consume the hot water is there in the tank for the whole day. You are losing the energy. So let us try to use the tankless water heater, where you instantly heat the water and use it. Then point number 8, install the energy efficient windows. When I say energy efficient window, how this energy windows can be efficient? Mr. Sengadir, when he talks about that, he will talk about this energy efficient windows. What it is, all the detail he'll talk to you. Then coming to the point number 9, upgrade your HVAC system. Still, I see many reciprocating compressors are running in many houses. It is very, very pathetic. They pay a energy bill huge, but they don't think by throwing out this AC, buying a new AC will give you a payback time of within a year, whatever the electric bill they pay. But still, they are running with a very old AC. Then weatherize your homes. See, many houses, there is an outside ambient is, there are a lot of leaks, lot of openings where ambient temperature that enters into the house and spoil the temperature. So there we have to have the weatherize. That means weatherize your home, which means sealing your home wherever unnecessary openings are. Then see, insulate your house. See, nowadays people, when I say insulated the house, there are so many ways of constructing the building. So we have to have this conscious to insulate the building where your energy is being saved. Then nowadays the washing machines all have come with a hot water wash. So only use the hot water when there is a requirement. So then point number 12, replace your all air filters. See, many houses the filter is not replaced nor cleaned properly. That is there for years, but they don't care about the inefficiency of the AC because of the filter. So please replace or clean your filter periodically. Use your microwave instead of a stove, because people are thinking stove may preserve the flavor of the food, but the microwave, though the energy is taken so much, but within a fraction of minutes that really heats up the food, and it saves very good energy. So use natural light. See, in those days, in the earlier days, there was a light, sufficient light was there, because the building was built in such a way that the light is taken, not the heat. So that concept we have to adopt. Then again, dress appropriately for the weather inside and outside. The reason is we wear coat, shoot and all, and increase the temperature. That is again, we are wasting the energy. So with this small introduction, so let us start like proverb says, charity starts at home. The energy conservation starts at home. When you have this conscious, definitely when you become an engineer, when you design the system, when you do design the HVAC system, you will see what are the points to be taken care while you design. So Mr. Sengadir Selvan has got the rich experience in this, the energy side, and he will brief you how this energy conservation can happen in HVAC system. I welcome Mr. Sengadir. I hand over this to you.
Okay. Thank you, Mr. Ferno, for setting up this context. Sir, Organizer, sir, can I proceed or?
Yes, sir. You can proceed, sir.
Yeah, thanks.
Okay.
Okay. Good morning to all. I thank the organizers for this wonderful opportunity to interact with eminent scholars and students. Now, my name is Sengadir Selvan. I have studied mechanical engineering and a specialist certification in revision air conditioning engineering. Now, I have been working with Innoval Engineering International Private Limited as a director and principal consultant for the last 10 years. Totally, I have 22 years of experience in this construction field, mainly on the commercial buildings. Now we are going to discuss about we are going to we are going to discuss about commercial buildings and the objectives and the methods and the types of capacity optimizations and how we have to set HVAC systems and how it will improve occupant productivity and life cycle performance. Now, I understand that this particular technical series is majorly based on thermal plant efficiency. But however, we find that the commercial buildings are the energy guzzlers, and any opportunity that we have to reduce the energy consumption will have a great impact on the thermal plant or any other power generating plant. So here we are not going to discuss about green building ratings and other ECBC norms and ventilation and other building services. So okay, now we are not mainly from thermal plant industry, but we are from commercial buildings. But you can see the phenomenal growth in commercial buildings before 2000. I think 1999 or 1996. There were no IT and ITS industry. With the onset of IT in the ITS industry, the requirement for commercial buildings have skyrocketed, and the air conditioning becomes a mandatory rather than a luxury, which was the case earlier. So here you can see the annual change in energy energy consumption of buildings in every year. The percentage has been increasing, and the China is adding more buildings, but they are more energy efficient than us actually. So now the main point is that while we have to add many commercial buildings to sustain our economic, but we have to be very cautious about the energy efficiency with in the commercial buildings, and which is driven by energy efficiency through HVAC. Okay, so ECBC defines that any equipment, any building which has got more than a peak demand of 500 kilowatt is defined as a major commercial building. It can be a hospital, or it can be a hotel, or it can be an office building, anything. But those things are referred as commercial buildings. Okay, so what are the commercial high performance buildings? Like, we should have a energy efficiency, and it should have a healthful environment inside, and it shall be sustainable towards the environment that we are building, and it has to be durable. I mean, it has to be maintainable. Okay, so throughout this presentation, we are going to discuss about each measures that we need to adopt in bringing energy efficiency in a HVAC system. So what we have done is that we have taken a similar building, and we are trying to compare the energy efficiency measures effectiveness. Like we are doing, we have done annual energy simulation, and the annual simulation cost is actually compared with the capex and life cycle cost. So here you can see in a commercial building, the HVAC demands 53% of your total energy consumption. So the bigger the challenge, and the bigger the opportunity. Yes. So we have a HVAC. Yeah. Is there any question?
Yes, sir. You can proceed, sir.
Okay, so now we have taken a one IT. Okay, and for we have taken Chennai as a location, so that the ambient. Okay, the ambient condition of Chennai has been considered for our all calculations. Now you can see we have taken 40-degree dry bulb and 28-degree wet bulb as your ambient temperatures. Now there are other considerations. Okay, I think I am it is getting muted every time. Okay, so the 40-degree temperature is something that we need to be very careful on energy efficiency. And ISRE and ASHRE have defined the weather weather temperature that you have to consider. Higher the weather temperature or ambient temperature that you are going to consider, it is going to increase your capex as well as sometimes opex also. So we people will say that Chennai is hot and humid, but if you see the average temperature or the occurring temperature in Chennai throughout the year will be around 32 or 33 degree 60% of the time. So we need not to design the system for 42-degree or 43 and all, which somebody tend to do that actually. Yes, there will be some peak temperature for few hours only. So ASHRE defines that you should use 4% of the peak temperature that is occurring. So we need to be very careful on the selection of ambient temperature while designing the system. And now again coming to the room temperature. Yes, the room temperature requirement varies from one industry to other industry. Like in a thermal plant, we have air conditioning mainly for the electrical rooms or the dry rooms or control rooms. So people tend to assume that having a lower temperature improves the durability or the life of the system. It is not the case actually. We have to find a optimal room temperatures. For a electrical room or control room, 25 to 26 degree is sufficient, and for an office space, 24 degree is sufficient. Again, as Mr. Fernoso suggested that the clothing also the occupant clothing also has got a major impact in setting up the temperatures. Like if we are normally clothed with the cotton clothes and all, our body will still feel very comfortable at 25-degree, and every 1 degree reduction in HVAC plant actually increases the energy consumption by 2% actually. So we need to be very careful in selecting the indoor temperature. And there are fresh air flow rate defined by ASHRE 62.1 standard. So we need to consider that, and it is very mandatory. Though fresh air increases the energy consumption, but it is a good trade-off to get a healthy environment inside. And for electrical rooms or for machine halls in thermal plant, the minimum fresh air shall be allowed inside, so that the we are maintaining some positive pressure inside the inside those critical rooms, and so that we avoid ingression of dust and other unwanted particles inside these critical rooms. And now for this all calculations, we have considered 12 hours of operating schedule. And now again, the number of people are taken from general national building code standards. And you can see the lighting load is considered as around 0.8 watts per square feet. Whereas nowadays there are systems available which can give you 0.4 watts square feet also. There are lights, which, I mean, in addition to LED lights, we have got addressable lighting. People say it's a PoE based lighting, which can get you the peak load of around 0.4 watts per square feet only. And there are some server requirements that we have considered. Okay, now you can see the one small building to the bottom corner to the right side. You can see the building is fully glazed, and there it is like a window wall ratio. WWR is window wall ratio. Now it's 96%. Actually, this is not an optimal one. Now having glazing for the entire building, actually it is like aping the European concept wrongly in India. Of course, there are advantages in terms of maintainability and all to have a glazing, but however, the energy consumption of a commercial building with a window wall ratio anything more than 40% is actually very huge, and it is not sustainable for our country or our weather profile. In Europe, the glazed buildings are generally given mainly to harvest the ambient sunlight, which is rare there. But here that's not the case. So here we need to reduce the window wall ratio, and wherever we are using the windows, we have to use very energy efficient envelope things. So now here you can see. In this case, we consider in a base case we consider a normal brick wall, and for a base case we consider single glaze fenestration, and in the roof we consider normal concrete slab, and floor a regular floor. And here we have considered 50 m thick XPS insulation or any equal insulation as an underdeck insulation for the roof. This is mainly to avoid the radiation heat getting into that one. So now you can see with the base case we have done the calculations. You can see the envelope load itself is around 32%. I mean, envelope load means your load due to your fenestration and wall and roof and floor. Now the internal equipment actually constitutes very smaller percentage compared to other load. The computers and other printers and all, it's very negligible in any commercial building. Of course, in a thermal plant, the electrical or the heat dissipation from the electrical panels is very low, but the heat dissipation from the VFD drives and other server or other critical equipments will be a little bit high actually. But again, the people load is only 10%, and the fresher load you can see. Chennai being a humid weather, the fresher load is actually high. But if you can say the same fresher load will be around 10% only if you are having this building in Hyderabad. Okay, so within this envelope load, I mean, what we you can see, we have taken the base case building as 96%, where the window wall ratio was around 96%. You can see out of around 210 TR, the 183 ton is actually required for windows only. So 70% are through windows, and the floor through floor it is very less only, and roof also it is very less, mainly because we have a underdeck insulation. And for through walls, since it's a brick wall, we have only 13%. So you can see that the majority comes from windows, and that gives the bigger opportunity. Okay, so generally, there are two methods of heat ingression through the fenestration. One is through radiation, and another is through conduction. So now we have taken single glazing as the base case. So here, 47% of our heat ingress through windows is through conduction or by means of conduction. Now, if we improve the U value of this glazing by going with double glaze, yes, there will be a slight savings. But however, the majority of the heat gain is through solar, SHGC, I mean solar heat gain through radiation. So now what happens? Chennai being a tropical city, and the solar radiation watts per square meter through west side is higher. So it is preferable to have the long facing wall or fenestration in north south instead of west and east. I mean, yeah, we have to reduce the west side exposure more actually, where the solar heat radiation intensity is much higher. And the second thing is that we should have we should reduce the direct exposure of glazing. We have to have shade, so that the radiation is the SHGC coefficient is reduced. You can see, I think I have seen in Anna University or the old buildings, the fenestration quantity is reduced, and even if we have glazing, we have a very huge fins around that, like some kind of boxing around that. So these kind of shades are very much important. Even if you can see, very olden buildings, though it is not air conditioned, the window part will have a some kind of a large shading, and so this is mainly considered for reducing the solar heat gain through radiation. Okay, now we have we have gone through that. Based on the base case, we have seen that we need 1 second. I will just go back. Yeah, we need around 750 TR of air conditioning capacity that we need. Okay. Sorry, the system is a bit slow. Okay, so now sorry.
Sir, is it okay, sir? Is this slide air conditioning
Yeah.
slides?
No, we go to next slide, sir. Slide number 15. Okay. Next slide, please. Yeah. So the annual energy cost. So what we have done is that we have considered around 10 rupees per unit. So the orange color is mainly for the electric screw compressors. I mean, electric chillers with screw compressors. So here, as a base case, we consider as the highest energy consuming equipment. There is air-cooled chillers. And since reciprocating compressors are outdated, I consider screw chillers. Now, with the screw chillers, you can see the 80% or 70% of our energy consumption in a commercial building goes to the chillers, and the pumps generally it is around around 5 to 6% of our total energy HVAC energy consumption. And the pumps only for circulating the chilled water from the generating point, that is chiller, to the load, that is air handling units. Now, in the air handling units, it's like your split unit, indoor unit inside that one. It will have a cooling coil and it will have a fan inside. So the fan consumption is considerable here. I mean, it is higher than the pumps, mainly because the specific heat of air is 4 times higher than water. So we need to have a lot of air to transport the cooling energy from the chilled water to the air. Actually, you can see that correlation. Okay, so now what we have discussed the base case. What we have as a common base building, and we had a single glaze and all, and we had seen what is the capacity that we needed and how much the energy it is going to consume. Now, I have not given in kilowatt hours, but I have considered 10 rupees, so you can check that. Okay. Now, in the base case, we have taken the U value is around 5.0 watts per meter square Kelvin. But here you can see as an energy conservation measures, and except north side, because in north side anyhow the solar radiation intensity is low, so we are not considered that. So here in we have considered 1.5 as the U value. So as we discussed that, we are by reducing the U value, we are reducing the heat ingress by means of conduction. And in solar coefficient, earlier in the base case was 0.39, and we are now going to consider 0.23. Now, in the double glazing, by through special coating, we can reduce the shading coefficient. You can see in many buildings, people will apply some kind of shade, some stickers or some film to reduce the shading coefficient only, and it will not reduce the heat energy conducted through conduction. Okay. So now by changing the AC load, by changing the fenestration, we have now reduced the envelope load by 26%. And pressure load, yeah, it is almost same. Yeah, I think the envelope load instead of 238 TR, now it has been reduced to 173 TR. But there is no change in internal equipment load or fresh air load and all. So mainly the envelope load, by changing the single glaze to double glazing in our base case, we could save around 50 TR, which is around 10% of the entire load. We could do that actually. Okay, now we have discussed about in the base case or in the energy conservation number 1, we have changed the single glaze to double glaze. So here what we are trying to do, the window wall ratio, we are trying to change it from 96% to 45% actually. So here you can see, okay, AC load here from ECM1, we have reduced 31 TR. Okay, from 118 TR of fenestration load has been reduced to 76 TR, and the wall load is actually increased here because earlier in ECM1 the wall load was 31 TR. Now since we are reducing the glazing, we are increasing the wall load, so it is gone up actually. But if you see overall, we are having around 130, 138 TR, which is still much better than your earlier around 215 TR actually. So around 100 TR we have reduced now by changing the window wall ratio to 96 to 45% and changing single glaze to double glaze actually. Okay. Now I think we have already discussed that the roof will be having only some underdeck insulation, but still the roof takes care of the roof is exposed to sun radiation to a larger extent compared to other glazing and all. So we need to see that an opportunity to reduce the energy consumption further. So what ECBC plus, that is the stringent ECBC requirement says that the U factor for your roof shall be 0.34 watts per square meter Kelvin actually. In order to achieve that, we can have some kind of vegetation in the roof, and we can have some better insulation layer and all. So vegetation roof itself reduce the radiation load by 50%, and this is what ECBC recommends. So you can see a comparison from base case 742 TR by reducing the single glaze to double glaze. We have brought down to 653. Then by reducing the window wall ratio, we have reduced to 642. But with the better roof, we have reduced to 578. So you can see the reduction is very huge in the roof, or through having a green roof. So now in the if you have commercial building, it is better if you can put some kind of shamina or some kind of tent, or you can use that space, some kind of shaded area which will have a huge impact on the heat load through roof actually. So what are the next big opportunities? So now we have seen that by working out working out different options in the envelope, we could reduce the heat load from 744 to 578. This is approximately 25 TR 600 and around 160 TR, and 160 TR is around 25% we have reduced only by working on the envelope. Now, what is the next big opportunity? Okay, as we discussed earlier, we need fresh air mandatorily, because we need to dilute the CO2 concentration within the office space for the human health and better productivity. Now here, by bringing the fresh air, it is going to increase the energy consumption. There is no way. So we have to see how we can conserve the energy that is given to bring the fresh air. So the first thing is that when the ambient temperature is say 95 degree Fahrenheit and all, instead of directly bringing the fresh air, what we can do is that we can use the cooling energy or residual cooling energy in the exhaust air. Now, what is exhaust air? Now, in a bottle of water, if you want to fill that, you will fill that. Then, if you want to add for more water, or you want to add fresh water, you have to exhaust something. So you'll anyhow drain the some water in order to bring the more water. So this exhaust water is equivalent to exhaust air. You need to exhaust a small amount of air. So but we are going to exhaust the cold air to the ambient. What we are going to do, that cold air we are going to use it to pre-cool our fresh air. So that is heat recovery unit, or somebody will say energy recovery unit. And in this, you can see this wheel. In this energy recovery wheel, we also have a desiccant coated, so that the latent energy in the fresh air is also recovered actually. Okay. So in this energy conservation 4, you can see all the heat load components are same. But you can see suddenly earlier the 150 TR was required for fresh air conditioning. Now it has been reduced to 61 TR. That's a phenomenal reduction. So by employing energy recovery wheel, we could reduce the heat load by around 80 to 90 TR. That's huge actually. So you can see the ECM1, I think, the ECM1 brings 12% reduction, window wall ratio reduction brings 14% reduction, and the ECM4, the HRW reduces 35% from the base load actually. 35% is from the base load actually. Okay, and yeah, you can see. Okay, what is it? Okay, okay, now generally, there is a thumb rule or okay, thumb rule or some issues other. Sir, just give me 2 seconds. Let me have some water, please.
Yes, sir. Sure, sir.
Yeah. Okay. So here you can see, in a general case, the air conditioning capacity per square feet, like it was around 259 square feet. We need a 1 TR. But now with this ECM4, we need we can stretch up to 400 square feet per TR actually. And as I was telling that in general industry, people are saying that you have to consider 150 square feet per ton and all, which is kind of very outdated. And I have seen still buildings are designed based on thumb rules, or even a small air conditioning, or even a large thermal plant like also. People just don't go through this kind of analysis. They just put that. In fact, even in your in a residential building, people just go with 1.5 TR, where your requirement is hardly 0.5 TR or to 0.8 TR. And people feel that, okay, I get faster cooling or faster cooling achievement, and that is actually very wrong. And the additional counter load capacity creates a large burden on the electric infrastructure, starting from your local area transformer towards the thermal plant that is generating the power. So it is it is prudent to analyze the air conditioning capacity selection or OPEX selection like this only. And there are many softwares available like HAP, eQuest, Tracer, and all. I think we can help. You can share any inquiry, and we can assist you if at all, if you are interested. Okay, now we all so far discussed about the capacity reduction that we have done by various measures. Now, how it is related? How it is related to the annual energy consumption? Now, by having all ECM4, we have a 55% of annual energy cost reduction. Earlier, you can see though our capacity reduction was only 35%, but however, the annual energy cost is reduced by 55%. So while we are doing this design, also we need to simulate the energy consumption also. Then we have to select the systems accordingly. Okay, now this is so far I have captured about how the system shall be designed and some energy efficiency measures. Is there any are there any queries? Dr. Sir, should we take some questions, sir, now?
Yes, sir, sure, sir. You can, participants, if you have any questions, you can ask them. Sir, we can have a session after the end of the your lecture, sir. Question
okay. Fine, fine, sir. Fine, sir. Okay. So we have another 1 hour time. I think we can capture other points. So now in this base case, we have discussed that we need to have around 750 TR. Then with many other energy efficiency measures, we have brought down to almost 500 TR. So now for 500 TR, our selection will be like 2 into 250 TR as the working chillers. Now for the type of chillers, we are considering air-cooled chillers with screw compressors as a base case, and pumping we are considering constant primary. Now in the constant primary system, the chilled water pump is actually used to circulate the water or chilled water from the chiller to the load, that is AHU, and bring back the warm water back to the load actually. Now this pump is running in full speed always. Now how we can save energy, that we can discuss now. Okay, the fifth energy conservation point is that we have chillers that are working in VFD mode. Even in air-cooled chillers, the compressors can be fitted with variable speed drives, and even the condenser fans also will be provided variable speed drives. Now why do we need VFD, and how it actually justifies this inclusion? Mainly because the entire air conditioning equipments are selected for the peak load that is going to happen either 0.1% of time or 4% of the time. Now I have designed a system for say 500 TR, but my average load, if I take, it will be around around 300 TR only. Is there any question, sir? Okay. Now we have a large opportunity to conserve the energy by using VFD drive. You can see this left side chart where without VFD, non-VFD chillers are slightly efficient at 100% load. But wherever after 80%, these are huge inefficient. And the y-axis talks about kilowatt per TR. There is a specific energy consumption for this air-cooled chiller. So per TR, in 100% load, it will be taking around 1.2 kilowatt per TR for Chennai condition. Now this one we have taken for 38 degree, which is the average temperature that we have considered, average peak. So with the VFD, you can see after 80%, the energy efficiency or the specific power consumption is coming down drastically. And the difference is much more when your ambient temperature is lower. So I mean VFD and nowadays many chiller manufacturers are making this VFD as a default option in their provisions. Yeah, of course. VFD brings other side effects like harmonic generation and all. So it is very important to consider sufficient capacitors or harmonic filters so that our power quality is maintained at the load, without compromising on the upstream electrical infrastructure. Okay, now the energy conservation sixth measure is water cooled screw chillers, and the seventh measure is even the water cooled screw chillers with VFD. Okay, now air being as a free resource that we are using to remove the heat through condensation. Now it is available at a elevated temperature, but water is available. I mean, if it is easily available and it is available at say 30 degree or 28 degree in Chennai. So then obviously when we are using a lower temperature coolant medium, the lift of the compressors will be reduced, and the power consumption in compressors is hugely reduced. Always you can say that there will be a 40% reduction by in compressor power consumption. Of course, there will be a increasing condenser water circulation and coolant tower fan power consumption, but still overall you will generally get 40% energy consumption if you use water as a cooling medium for your chiller. Now the water cooled screw chillers is available with VFD. So 6 and 7, and the 8th point is that now the load at the AHU is also not always common. Based on the ambient temperature fluctuation or based on your load fluctuation, internal load. Generally in thermal plant and all, the internal load or heat dissipated through the electrical equipments or drives will be always constant. But for commercial building, for morning 9 o'clock there will be a different load. 12 o'clock there will be a different load, and 1 o'clock it will be different load, mainly because people will be out for lunch and all. And by 3 o'clock, it will be peak load because of the sun radiation effect. After 5, 6, you'll see the temperatures dropping down, ambient dropping down, and there will be a different load. So when the load is hugely pulsating at the AH level, it is not necessary to always circulate the same amount of water. So we can circulate the required amount of water only based on the load. That is why this concept came, that the secondary variable pumping system. Now the right side pump, secondary pumps will be fitted with VFD, and it will be modulated to meet the load actually. But there is a small issue that the source, that is chiller, needs, I mean, olden days chillers needed constant flow of chilled water inside the evaporator, only to maintain some velocity over the coils. I mean, there was a olden days actually. Nowadays there are chillers which are available, which can take up minimum flow rate of 60% actually. So here we are having these pumps in a variable speed, and this primary pump to the left side will be in the constant speed. We have broken that hydronic system, and we have a small hydronic decoupler line also actually. And as I told you, nowadays the chillers are available with a minimum flow up to 60% also. So what we are trying to do is that we are we are adding VFD to the primary chilled water pumps, so that it will be modulated to meet the minimum load of our load side, or it will modulated to minimum flow requirement of the source side actually. So that is called primary variable system. So that is energy conservation number 9. Okay, so how these are relating to annual energy costs? By having a different type of chiller or different type of pumping does not change the load, because I mean, all these things are in the generation side. So we don't have to compare the capacity reduction, but we have to compare the annual energy cost reduction here. So we saw that the energy conservation measures 4 was reducing by 55%. Now energy conservation measures 5 is changing the air cooled chiller to water cooled chiller. So we have another 10% reduction overall actually. Though there is a reduction in chiller power consumption by 40%, but overall it is 10% only. Now by adding VFD, you can see we have a huge savings, like 93% savings actually. Now the next thing is that another 2% reduction by having a water cooled the variable pumping system actually. This is 8, 7, and 8, 9 are all pumping systems. But overall, you can see where the energy consumption was around 178 crore, or you can say it is around 17 lakhs unit. Now it is reduced to 8 lakh unit, or 8 lakh kilowatt per hour. So that's a huge savings, or huge potential is there still. Now it is very important to analyze these things, because each weather conditions or each building internal load profile different, and the energy savings percentage will vary. For an air conditioning of a factory, we have recently saw that by increasing the room temperature from 23 to 28 degree, we could reduce around 130% of energy consumption. So still, this point is not captured here, because we have kept the ambient internal temperature constant. So we need to do this analysis, these kind of softwares, so that we select the right system and energy efficient system for our requirement. Okay, now how the selection of energy efficient systems related to occupant productivity, or how other energy efficiency measures can be still considered. Okay, so you would have seen many IT buildings with fully glazing and all. This is one of the design for a building in DLF in Chennai, where we have a huge software buildings, and the buildings are fully glazed. So what happens? This glazing side area, we have selected a bigger duct, and it's called variable air volume boxes. It's a motorized damper. Now we have designed such a, we have given a zoning in such a way that only that area which demands more air quantity or more cooling, it is given more air. So such kind of zone control is very much essential. In absence of zone control, we have seen people are struggling to maintain a required temperature pattern. So in one part of the room, people will be very cold. In other part of the room, people will feel very warm actually. And in order to meet the warm area, we will be running the air conditioning at the lower capacity always, which will increase the energy consumption to a large extent. So for better energy efficiency, this kind of zoning control is much required, and also it helps on the occupant productivity. I mean occupant comfort and productivity. Now the additional fresh air. Yes, we have discussed about the fresh air. Now it's so far in all surveys, people find it very giddy or headache kind of illnesses for a longer stay of stay inside the air conditioned buildings. So our green buildings ratings mandate that we should have additional 30% of fresh air. And the other point is that we can have an elevated airspeed. Now, I think the Berkeley University has come up with this wonderful tool, like by improving the air velocity around your body, you can go for a higher temperatures. It is like, when we are sitting in a bus or train in a standstill condition, we feel very much suffocated or very much uncomfortable. But the moment the vehicle starts moving, you'll see a breeze of air over your body, and though the temperature is not reduced, you'll still feel comfortable. That is through your wind chill effect, that sudden evaporation of moisture in your skin increases the heat transfer. So this way, by having an elevated airspeed at 24 degree, it increases the human comfort. Also, it allows you to go with the higher temperature. So generally, people in my home, we generally set the temperature of AC by 28 degree, and we use the ceiling fan. So that way, you still feel the comfortable, and your energy consumption is low. Okay. Okay, we have discussed about the zone control and 30% additional fresh air, and ECM 11 means your increased temperature. Instead of 23 degree, if you are setting it to 25 degree, how much? So you can see that the power consumption from 81 lakhs is reduced to 77 lakhs. So there's a huge reduction, mainly because by increasing the room temperature to 24 to 25 degree. Of course, here the energy consumption is increased mainly because we bring additional 30% fresh air, but that is now required for the human health. So you can see the annual energy cost. Okay, sorry. So we have we have brought down the energy consumption from 1.78 crore rupees to 0.7, around 101% reduction by various means, internal these things. Okay, the other point is that the life cycle cost analysis. Now, okay, now I want to reduce 5% of energy. Now, can we spend 2 crore just before that, just because of that? No, it is waste and it is not sustainable from economical point of view. So we have to consider the balance between capex and opex. And the third thing is that the lifetime durability of the equipments. Nowadays, for any commercial buildings, it is easy to put split units, many split units. But these things will last mainly for 10 years only. So the lifetime durability of the equipments also shall be considered. And your service cost. Generally, having more equipments or small equipments, more equipments will bring additional maintenance headache, and it will drive your maintenance cost or your service cost. It also increase your maintenance cost. I mean, preventive maintenance cost also. So you need to find a balance between all those aspects. So in order to do that, there's a thing called the life cycle cost analysis. We are going to discuss about that. So what we have discussed is that now in the single glazing, we are we should have spent around 3.7 crore. By double glazing, yeah, we have to spend 3.8 crore. So if you can see all these measures, in base case, we should have spent 7.57 crore. In ECM 9, it is 7.67 crore, because generally 10 and 11, 12 and all are smaller one, and it is a mandated things. But here you can see, by spending only 10 lakhs extra, we could reduce the entire power consumption by 10%. I think you can see that cost difference also in ECM 9. Okay, from 1.78 to 0.8, around 90 lakhs we have reduced. 90 lakhs we have reduced by spending only say 10 lakhs extra. By spending 10 lakhs rupees extra, we have reduced the energy consumption by 80 lakhs. Now you can see we have added the electrical infrastructure cost differences, makeup water cost differences, and everything added. So the investment cost is same. Okay, so the base case, if you are spending some amount for your capex and opex and maintenance cost also, the 10 years, the base case building, you have to spend 25 crore, whereas with the all energy efficiency measures, you have to spend only 15 crore. So there is a huge reduction. 10 crore will be saving in 10 years. So averagely, you will be saving 1 crore in a year actually. So this is how this life cycle cost analysis is done, and this is how we have been doing it for our commercial buildings all along. I think I have completed the session much before the assigned time. I'm sorry for that. I think we can take any questions now. Sir, Venkata sir.
Yes, sir. Yes, sir. Participants are advised to take any. Please, if you have any queries, you can ask. So, no queries, sir. Then, so thank you, sir. I thank Mr. A. Ferna Susai, founder and MD ADS Chennai, and Mr. K. Sengadir Selvan, Director Renewable Engineering Chennai, for handling this 7th session today, and their deep insight into the energy conservation and HVAC system in different angle will have opened a different view of HVAC systems for participants. So I thank you once again, sir, Dr. K. Sir, Mr. K. Sengadir Selvan, sir. Thank you very much, sir. Thank you for sharing your time. Thank you very much, sir.
Thanks. Yeah, thanks a lot. Thanks a lot for the opportunity, sir.
So now we will continue with what Dr. M. Venkata sir left in the previous session. So over to Dr. Venkata sir. Sir, please.
Thank you, sir. Thank you to the speakers who were kind enough to have their time in short notice. Yeah, in the last class, we have seen about energy audits, what we were seeing it from day one. And we were able to see how the energy transitions happens from the source to the utility. There we have seen out of 100 kg of coal, what that was available onto the plant, onto the thermal power plant, approximately 2 kg of coal gets converted into light. You can see out of 100 kg of coal, what that was fed onto the whole power plant, only 2 kg equivalent is available as light. This is the amount of energy loss what we incur. So whatever we save on the energy front, it will be much helpful so that we'll be able to save a lot on the environment also. Like, okay. Now, the basics about energy audit was informed earlier. Now we will see minor aspects also. It becomes easier. See, energy audit wise, as was informed in the first class itself, this is an balancing measure. We balance the amount of energy, whatever we gave as input as compared to wherever it has gone. Like, so this is an analysis through which we'll be able to quantify whatever we quantify. It becomes easier for us to monitor. If you don't quantify, monitoring becomes difficult. Ultimately, we lose. Like, so energy audit is also an exercise whereby we'll be able to quantify the amount of energy that we take. This is one step. Second, if you take the utility, we'll be able to balance out of how much amount of energy input I gave, what are the various applications of it. Third, the most important one, we'll be able to check the current performance of the plant. If, for example, since the first session was on HVAC, normally we tell kilowatt per ton. What is the power consumption that the system has taken for every tonnage of refrigeration, kW per TR. Once when you are able to establish this one for your house, you can check whether it is on par with the latest ones. Like, if there are some problems in the condenser coil or in the evaporator coil or in the filter and all, we'll be losing higher amount of energy. Ultimately, the COP or the efficiency of the air conditioning plant would be lower. So this kW per TR, it will become higher. Like, so energy audit is an assessing mechanism through which we'll be able to ascertain how we perform. This is case 3. The last one, the most important one, the one which delivers substandard output. Assume that I have 10 fans in my house. Like, there will be some fans which will be giving lower amount of wind as compared to the amount of power what it takes. Like, fan is a small example I gave you. We can take air conditioners. We can take, suppose if it is an industry, we'll take electric motors, pumps also. Likewise, you can take all those things and all. We'll be able to grade, and then accordingly we'll be able to identify the culprit. Accordingly, it becomes easier for us to replace them or repair them. Okay. Next comes a basic question. Basic question: why we have to do an energy audit? What is the need for us to do an energy audit? There are different things what people tell. The last two, what that is being mentioned here, this is Naam ke vaste. Just for the namesake, it will be done. Like, whereby what people tell is that if at all we save energy, we'll be able to have higher longevity of the existing fuels. That is case 1. Second, environmentally benign environment advantages. Honestly speaking, no industry will be thinking about the last two. This is what that happens even now. There is what that happens even now. All industries would be focusing on only one aspect, money, and the return on the investment. Within what interval of time I'll be able to have the investment, whatever I've invested upon. So first and foremost aspect for doing energy audit is not to save on energy or not to check on environment advantages, but for the industry to save on the money. How much amount of money that I'll be able to save. This is case 1. The more the amount of money, more would be the profit. I'll tell it with an example. It becomes much easier to comprehend also. It becomes much easier to comprehend also. If we will take one small pen. We will take 1 pen. Okay. Any idea what is the difference between cost and price? Any idea what is the difference between cost and price?
Cost means it is the manufacturing cost, and price means considering profit.
Superb, sir. Superb, sir. So, the expenditure, whatever I have incurred in making 1 pen, it is called as cost. Cost plus profit, this becomes our price. As you people would have seen, in each and every commodity we buy, as per Indian government norms, we'll be having MRP, maximum retail price. They tell what is the price that has to be fixed upon. Okay. Now, for making any commodity or any item, there are some costs what that is involved. To name them, we will take the first one as raw material cost. Second, there will be some water what that is associated with it, so we have to go for water cost. Third one, we have to depute manpower, so manpower cost will be there. Fourth one, interest on the investment. Interest on the investment, so that interest cost would be there. Like, then rental expenses, all those expenses will be there. All those are cost. Like, depreciations would be there. That also has to be accounted. Like, and also there is one more cost what we people work around, that is nothing but our energy cost. Yeah. Apart from this, there will be some others which we can have it as etc. etc. Okay. Now, among these, now assume that there are two manufacturers, manufacturer X and manufacturer Y. Both of them make the same product, which is nothing but our pen. The cost what that is associated with making a pen is identical for both the people. For X and for Y, it will be same. For X and Y, the cost that is associated will be same. Like, here, there is one advantage. Probably the cost for making a pen is assumed that it is ₹6 per pen. I'm able to sell it at ₹9 per pen. My profit is ₹4 per pen. This is the manufacturing cost. This is the price what that has been fixed through. Clear? This manufacturing cost includes all these factors, like, and these factors will be common for any industry as such. Like. Here, the only cost what that an industrial entrepreneur can control is the energy cost. Rest all things, it will be common for both X and Y. The only one which gives him an edge over the competitor is with what energy efficiency he is able to make a product. If he is able to make a product at a much lower energy, then this cost would have become ₹5 per pen for him. So his profit margin would be ₹1 per pen, approximately 10%. Approximately 10%. If he wants to sell at bulk, since the cost of the pen is ₹6, since the cost of the pen is ₹6, Y cannot quote a price which is lower than 6. But X has a liberty where he can quote ₹5.5 also per pen. So that's the advantage. That's one major input what we people can have it done. Like, so energy cost will give any industrial entrepreneur to survive in the present competitive market. I think you people would be aware, like post-COVID, it has become even more stringent. Like, the raw material cost had become higher by 30% at least. And day before yesterday, I was able to witness one case whereby the subcontractor is asking the person to reduce his manpower cost by 10%. So this is the competitive things and all, where if you are able to cut down the cost, it becomes easier for you to have the order. Otherwise, it will go off. Like, so energy audit will give us an option whereby we'll be able to survive well in the present competitive market. Okay. One important aspect what people wouldn't be aware, saving 1 unit of electricity, you will be able to save ₹500,000 every year. saving just 1 unit of electricity, you will be able to save half a lakh of rupees every year. This is an example of how it is being done. 1 unit of electricity, we will take the average cost as rupees 5.75 per unit and 8,760 hours. This 8,760, I think you people will be aware. 24 multiplied with 365. So once when you save just 1 unit of electricity, we'll be able to save half a lakh. We'll be able to save half a lakh. So that's the cost component that is associated with the savings. Like the monetary savings, honestly speaking, it should start from our house. You can have this as an impact. You can start from your house. Like you can start doing various options through which you can save energy. After the end of the class, probably at the last session, I'll be having some time whereby I'll be able to tell you some simple tips whereby you can save the energy at your house. Like as a result, you will be able to save approximately half a lakh every year, or you can purchase 2 sovereigns of gold so that your house people would be happy. One important factor, what we normally overlook, energy cost accounts for greater than 95% of the product's life cycle cost. Energy cost accounts for greater than 95% of a product's life cycle cost. Let me tell it with a simple example. Purchasing a bike is easier. Fueling the bike with petrol during its entire lifespan becomes difficult. Purchasing an elephant, owning an elephant is always easier, but feeding the elephant becomes a major problem. The same thing also happens over here. Assume that we have a case study. Assume that we have a fluorescent tube light, FTL. The cost of a 40-watt tube light will be approximately rupees 60. This is the capital investment what I make for the lamp light. The power consumed by the lamp, it is 40 watt and 15 watt for the choke. Conventional, if it is electronic ballast, it will be taking only 3 watts. Conventional tube lights, what we people have, it will be so much like. And now off late people have gone in for LED tube lights. You will be able to get an LED tube light at rupees 200 per piece. 1 minute. Yes, sir. Okay, sir. Sorry, sir. Sorry, sir. Okay, sir. Sorry, sir. Sorry, sir. Right, sir. Sorry, sir. Okay, fine, fine. Thank you. Thank you. Thank you. Yeah, it was an admin call. Okay, now see, the power what the tube light has taken was 40 watt for the tube light to glow and 15 watts for the choke light. So total amount of power what it was drawn was 55 watts. Like, let us take the lifespan of a tube light as 2 years. See, the lifespan what people tell us that you have to switch on the type lamp and you should not switch off. Typically, the lifespan of any luminaire, what people inform us, you have to switch on and you have to make it to live its life. The more frequent your switching on and off happens, the lower would be its life. So this is the life what they quote like approximately 2 years. So for 2 years of this FTL to glow, the amount of power what it would take is, I'm converting this 55 watts into kilowatts. It goes approximately 12 hours in a day. Parking bay, assume that it is available in the parking lot, like 365 days per year. 2 years is the lifespan. Rupees 5.75 is the per unit cost of electricity. This has to be kilowatt hour. So once when you do all these things, it becomes 2,770 is the energy cost what I have spent on the tube light. Including the capital cost of rupees 60, the overall total life cycle cost what I have spent on the tube light is rupees 2,830. If I divide 2,770 with the overall life cycle cost, the energy cost comes to approximately 98%. Hence, I was informing you, purchasing an elephant is a much easier task as compared to feeding an elephant. Purchasing a bike is easier as compared to feeding the fuel to the bike. So just have this in mind and then accordingly or appropriately choose the gadget. This is one more example. This is one more excellent example. People always see what that is visible to them. People neglect what that is invisible to them. Though the purchase cost wise and substandard item would be lower in cost, but during operation it will be taking so much amount of energy. Vice versa, the purchase cost would be much higher. The operation cost would be too low. This is applicable for star rated equipments. The more higher the star, if it is 5-star, the purchase cost would be more, the operating cost would be lower. If the purchase cost is only 1-star or no star, the purchase cost would be lower, but the operating cost would be higher. Like just have an understanding, like energy cost accounts for almost 95% of the total life cycle cost. There is also one more important thing what you people have to understand. Kindly do not go blindly for 5-star again. You have to choose as energy engineers, you have to choose wisely on the operating hours based on the hours of operation that you people have. I'll tell you one small example. Replacing an incandescent lamp with an LED, definitely it will save energy. There is no doubt on that. Replacing an incandescent lamp with an LED will definitely save huge amount of energy. No doubt on that. But the location where I change will be an important factor. If I replace an incandescent lamp in the parking lot, which glows for approximately 12 hours in a day, it is wiser. Because the operating hours is more, I'll be able to save automatically the amount whatever I've invested. Because LED lamps will be costlier as compared to the incandescent lamps. Like so, it is a good decision. Like, but I replace an incandescent lamp in the washroom, the occupancy of the room would be hardly 10 minutes for the whole day. Replacing it with LED, though it saves energy, but the investment return will be much higher for me. The lifespan of the bulb would be lost. So financial evaluation has to be done, and then appropriately you should take a call on which one you have to invest so that it becomes easier. Okay, now this is one typical power plant. This is one typical power plant. This is, it will be a definite eye opener for you people. The case study what we have taken is a 210 megawatt thermal power plant. This is what we call it as heat rate. As engineers, we will be aware about heat rate. That is nothing but how much amount of heat we supply for generating 1 unit of electricity. In simple terms, this is inverse of your efficiency. Because efficiency will be what is the amount of electricity I've got as compared to the amount of fuel that I gave in and the amount of energy, heat energy I gave in. Efficiency is the output as compared to input. But heat rate is what is the quantity of heat what that has to be supplied so that we'll be able to generate 1 unit of electricity. We have also another term, what we call it as steam rate. Steam rate is what is the kgs of steam that is required for generating 1 unit of electricity. These are the two different terms what we normally employ in coal-based thermal power plants, heat rate and steam rate. Okay. The second factor is plant load factor, which is nothing but 85%, or else in other words, out of 8,760 hours, the plant will be in operation for 85% of the time, and remaining 15% of the time it is down for attending for various other maintenance works. Okay. The coal that we have used in this plant, it is typical E grade coal. If you import, the calorific value of this coal will be much higher. It will be almost double because the ash content would be 10%. Whereas Indian coal, as I was informing you, 40% would be the amount of ash content. So approximately 4,000 kilocalories of heat energy would be available. Ultimate analysis reveals the carbon content in Indian coal as 41.7%. This is the cost what there is available. Coal India Limited supplies these coal to the thermal power plants, as you people would have seen in the earlier slide. This is the cost, rupees 2 per kg or rupees 2,000 per ton. Now we will see how much amount of carbon dioxide emission happens for every ton of coal burnt. 41.7, as I told you earlier, carbon plus oxygen, it will form CO2. 12 kgs of carbon requires 32 kgs of oxygen to form 44 kgs of CO2. Therefore, 1 kg of carbon gives how much amount of CO2? It is 44 by 12. So 44 by 12 times of 41.7. 44 by 12 times of 41.07. This gives 1.5 tons of CO2. So what it basically informs is that 1.5 tons of CO2 would be emitted if I burn 1 kg of coal. If I burn 1 kg of coal, which is having a carbon content of 41.6% or 41.7%. Okay. Now, the heat content of the coal is 3,997. The heat rate, what that is required is 2,450, accounting all efficiency factors and all. So the quantity of coal, what I should supply is 2,450 is the amount of heat what I have to have, as against 3,997 that is available with the coal. So 0.6 kgs of coal is required for generating 1 unit of electricity. I repeat, it becomes easier. 0.613 kgs of coal has to be supplied for generating 1 unit of electricity. If you multiply with 1000, automatically you'll be able to have it as tons per MWH. So for a 210 megawatt power plant, how much amount of coal it takes and how much amount of power that you'll be able to make. So 210 megawatt would be available here. This, as you people have seen, it will become 8,760 hours per year. This 0.85 is the availability factor. So 0.85. So we'll be able to generate 15.63 lakh megawatt hour. A 210 megawatt coal-based thermal power plant having a PLF of 85% would be able to export so much amount of power to the national grid per annum. Okay. So this number you have it in mind. You have all these numbers, it becomes much helpful. Heat rate is one important value what you people have to have, like 2,450 kilowatt hour per unit of electricity. Okay. Now the amount of coal. Now this is the amount of power what I have got, like, and this is the coal what that is required for every megawatt hour tons. So much, if you have these two factors, then so much tons of coal has to be supplied. See, approximately 10 lakh tons of coal is required for operating a 210 megawatt power plant. For operating a 210 megawatt power plant, the amount of coal that has to be supplied is approximately 10 lakh tons. Just imagine the value what we speak about is 4 lakh megawatt. This is the installed capacity, overall installed capacity. Probably on the slides, what you people would have seen, as on Jan 2022, 4 lakh megawatt is a total cumulative installed capacity. Just imagine the amount of coal what we should have it across time. But here again, we depend on coal for only 75%, all those things are all. But still, just have this in mind, like so much tons of coal is required for operating 210 megawatt power plant. Cost wise, if at all you equate 19,170 lakhs has to be spent on the coal cost. CO2 emissions, so much tons of CO2 will be able to emit for a 210 megawatt power plant, which is giving so much amount of power. Okay, now comes the energy audit aspect of it. By doing different measures, there are different measures. Probably if there is some time, I will try to handle you the Rankine cycle analysis. It will become an excellent topic. I'll be able to tell you what basically is reheat, what is regeneration, why we go for reheat plus regeneration, then why we go for supercritical power plants, then why the condenser pressure is maintained at vacuum. All these things, if at all I have time or in the last session, I'll be able to handle. Okay. So,
hello.
Yeah, please.
Sorry to disturb you, sir.
Yes, sir.
Can you please explain how that CO2 emission calculation is done in earlier slide?
Okay. Now let me go into the calculations. It becomes easier. See, we have coal with us. There are two analyses of coal, what we people do. One is called as ultimate analysis. Other one is called as proximate analysis. In ultimate analysis, the ultimate analysis will be able to reveal as cons: carbon, hydrogen, oxygen, nitrogen, sulfur. The ultimate analysis is also called as elemental analysis. It will be able to inform us the percentage of carbon, hydrogen, oxygen, nitrogen, and sulfur that is available inside the fuel. Whereas on the other hand, the proximate analysis will be able to reveal moisture content available inside the coal, volatile matter available inside the coal, ash content. 100 minus all these 1 plus 2 plus 3 will be able to give us fixed carbon. Fixed carbon is equal to 100 minus moisture content plus volatile matter plus ash. Okay. These are the two analyses, whatever we do for any fuel. Whatever fuel that you have, in order to ascertain the quality of the fuel, in order to check how it will be able to burn and various other aspects, these two are the prominent analysis what we people do. One is called as elemental analysis, or also called as ultimate analysis. Second one is called as proximate analysis. Now, this elemental analysis is basically done to estimate three things. The first thing is to establish what is the stoichiometric amount of air what the have to supply. Second is flue gas desulfurization that has to be done. Second is flue gas desulfurization that has to be done. Third, you can estimate the calorific value. There are again different methods. Bomb calorimeter will be done. Using the bomb calorimeter, people will be able to establish the calorific value of coal. Apart from this, Dulong's formula would be available. By having these values substituted into the formula, you'll be able to estimate the calorific value of the coal. Okay, now coming back to this one. Once when you do the elemental analysis, we'll be able to gauge the amount of carbon, hydrogen, oxygen, nitrogen, and yes, that is available inside the coal. The analysis what that we have done, the ultimate analysis reveals the carbon content in the Indian coal was 41.7%. So this value by doing elemental analysis has been arrived as 41.7%. Let me be precise, it becomes easier. If I take 100 kg of coal, that 100 kg of coal will be having 47.7% of carbon. Approximately, it might have 20 kgs of hydrogen, 20 kgs of oxygen, so it will become 80, 10 kgs of nitrogen. Sulfur, I'll take it as 8.3. So if I add all these things, I'll be able to have as 100 kg of coal. Now, we wanted to know the amount of oxygen, stoichiometric air. We do some analysis. Accordingly, we'll be able to have that one done. But we are interested to know how much amount of CO2 that this coal would be able to give. As you would have been aware, carbon plus oxygen, it will form CO2. 12 kgs of carbon, molecular weight of carbon. Molecular weight of oxygen is 32. It will be able to give me 44. So 12 kg of carbon gives 44 kgs of CO2. 12 kgs of carbon gives 44 kgs of CO2. Now I have to arrive at specific coal consumption for my plant. Specific coal consumption for my plant, for which I should know two data. One is what is the heat rate. Second, what is the heat content that is available inside the coal. This is CV content available with the coal. This is the heat rate what that is operated for the Rankine cycle power plant. These two informations were already available. 2450 kilocalories per unit of electricity is the heat rate what that has to be supplied. The calorific value what that was available with the coal was approximately 4000. So if I burn 1 kg of coal, 1 kg of coal would be able to give me 4000 kilocalories of heat. But I need only 2450 kilocalories of heat for generating 1 unit of electricity. So what is the quantity of coal what that is required for generating 1 unit of electricity? If that analysis has been done, it will become 2450 divided by 4000. This gives specific coal what that has to be supplied. So it means that I have to supply 0.6 kgs of coal for generating 1 unit of electricity. Now here, see, 12 kg of carbon, as we people have seen, it will be emitting 44 kgs of CO2. Now, as that was being done, heat rate we have seen it as 2450. Calorific value of coal has been taken as 4000. if you do these analysis, the quantity of coal what that is required for generating 1 unit of electricity becomes 0.6 kgs of coal for generating 1 unit of electricity. That is what we people have seen here. Clear? So this analysis informs like 0.6 kgs of coal has to be supplied for having 1 unit of electricity. See, here we have seen 12 kg of carbon gives me 44 kgs of CO2. I have 0.6 kg of coal. 0.6 kg of coal. So here it will be 0.6 multiplied with this coal contains 41.4. This into 0.41. This will be the amount of carbon what we have in the coal. I think you are able to follow, sir. Else, I'll remove this one. It becomes even easier. I will explain in one more step. It becomes even more easier.
Yes, sir. Yes, sir.
So this 0.6 is the amount of coal. Now, how much amount of carbon that is available in this coal? 0.6. The carbon content has been estimated as 41.7%. This is by 100. So if we equate that, 0.6 multiplied with 0.6 multiplied with 0.417. So 0.25 kgs of carbon is available in 0.6 kgs of coal, what that was used. So 0.25 kg, so 12 kgs of carbon, as we have seen, it was able to give so much amount of CO2. 0.6, sorry, 0.25. 0.25 gives 0.25 times 44 by 12. 0.25, this multiplied with 44, this divided by 12. Approximately, for generating 1 unit of electricity, you have to have 0.9 kgs of CO2. Okay, sir?
Yes, sir. Yes, sir.
Yeah.
Thank you.
So the amount of CO2 has been done. Now here, we were understanding like by doing these energy efficiency options and all, we were able to save 50 kilocalories per kilowatt hour. This is too low a value. This is too, that out of 2,450, as we people have seen, the heat rate what we have seen was 2,450. Out of that one, we are having only 50. So if you do the analysis, 50 by 2,450, just 2%. If I am able to improve the efficiency of the thermal power plant by just 2%, we will see what will be the impact of it. The heat rate earlier it was 2,450, now it would have become 2,400. The coal consumption earlier it was 0.613, but now it will be 0.6 as such. Accordingly, the amount of coal what you save will be so much, and the monetary wise, so much amount of money will be able to save, like 392 lakh rupees will be able to save. CO2 emission wise will be able to save so much amount of tons. These two values are applicable for a typical 210 megawatt power plant. These two values are applicable for a typical 210 megawatt power plant. Just improving the efficiency by 2%, so much would be the humongous savings that we people will be able to achieve. Okay. Apart from the general aspects, there are also other associated aspects of saving energy. The first one, what we people were doing as of now is that we'll be able to save 1 kilowatt hour. That is one. Apart from that one, as you people would be aware, the tariff structure wise, people bill based on the time at which we have the power. In our state, it is morning 6 to 9 and evening 6 to 9. This is called as peak hour. In Kerala, it will be different values. 6 to 9 a.m., 6 to 9 p.m. If at all you take power in these two interval of time, you have to pay approximately rupees 0.6 per unit of electricity as extra, because you are taking the peak hour tariff like. So this is an additional tariff what the people lay. This is one aspect. So by saving kilowatt hour, we'll be able to save on this aspect also. That is also a second advantage. First advantage is this. Second advantage is this. Apart from this, EB billing, if you understand, for all industrial sectors, We have to pay for kWh. We also have to pay for kVA. This kVA is called as contract demand. This kVA, it is called as contract demand. Let me tell it with an example. The fixed landline phone in our house, like monthly rental for the landline has to be paid, or even the house in which we people live, if it is a rental house, either we occupy or not, the monthly rental has to be paid. Likewise, the contract demand would be levied to the industries. So the contract demand, if I am able to save on the kWh, the contract demand would become lower. I can surrender the excess demand. As a result, I'll be able to save on the kVA demand also. By doing energy audits, our power factor will become higher. Power factor, if it is maintained more than 0.95, incentives are available. If it is less than 0.9, penalty has to be paid. If it is maintained between 0.9 to 0.95, no profit, no loss. If it is less than 0.9, penalty will be levied to us. Like if it is more than 0.95, incentive will be awarded to us. Like power quality would be better. If we schedule the things on all, voltage level across the whole industry would be higher. If the voltage level is higher, I or the current or the amps would be lower. If amps is lower, I square R would be lower. Coil life would be higher. Longevity of the equipment will be higher. Like increased availability. Of course, if these things are better, availability of the whole things will be there. At last, we'll be able to live in an environmentally advantageous one. Okay. The advantage of doing energy audits. First, we have seen what basically is energy audit. The second, we have seen why we are doing an energy audit. Third one, what is the outcome? I'll be able to fix my benchmark where I stand. I'll be able to assess my IQ level. Likewise, we'll be able to check if my industry is a cement industry, kilowatt hour I consume for making 1 ton of cement. If the example what I told was pen, what is the unit of electricity that I have it for 1 pen? If it is different industry, likewise, I'll be able to have specific energy consumption. For making one product, how much quantity of energy that my industry takes in. This becomes a benchmark for me, whereby I'll be able to compare with the industrial standards. If the kilowatt hour per ton of cement making for me is lower than the average of the industries, then it means that I'm operating in an effective manner, efficient manner. Unfortunately, if it is more than what there is available on the standards, then it informs that my process is faulty or my operators are at they are operating in a careless manner. So this becomes a yardstick through which I'll be able to check where I stand. Like, and if this value is very poor, it gives me a basis through which I'll be able to plan for altering the process altogether. Okay. And apart from that one, it is an effective tool for me to monitor the whole plant. Once when the industrial people, once when the worker is aware that the boss is checking the quantity of energy what I take for every shift, for every product, he'll become careful. If it is watched, then automatically everything will be done well. Monitoring has to be done. If the examination is conducted without monitoring, copying will be there. The output would not be reflective of what that was from the student. Like monitoring has to be done. As a result, we'll be able to have an effective outcome. Accordingly, it will be a tool through which we'll be able to have it done. Like this identifies inefficient and also misuse of energy. Misuse of energy, I'll be able to tell you one example what I have observed in the cotton mills and all. After the operation, the cotton paste would be there on the hair or on the cloth and all. You will not believe compressed air was used for cleaning the body. So these things do happen. Like so, once when you go for checking and once when you do energy audits and all, you will be able to arrest all these things as such. These are the three broad ways through which we will be able to do energy audits. The first one is called as preliminary energy audit. Second one is called as detailed energy audit. The third one is called as specific energy audit. We will go one by one. It becomes easier. The preliminary energy audit, this is also called as walk-through audit. WALK. This is called as walk-through audit, or this is also called as an observation audit under having skills or having industrial experiences, if you are a skilled energy auditor, just by walking through the plant, you will be able to observe the various inefficient operations. Yesterday class, you would have seen how the pumps are operated in an ineffective manner. The damper controlling is an example. Air compressor bandwidth operation will be an example. Air conditioners, hot well and cold well insulation, all those things are an example. The compressor type, what they adopt also will be an example. Evaporator, condenser, how they are operated, all those will be revealing how the whole plant is operated. Like, clear? So you walk through the plant, you observe the plant, how it is being done through. You will be able to understand where are the wrong things, what that are happening. This preliminary energy audit is done for two purposes mainly. First one, to fix my quote. What is the cost that I have to do for the study? First one. This quote would be dependent on what manpower I should have it across, what instrument I should bring. What instrument I should bring, like. See, instrument wise, I think we have one more additional talk on that day. The sophisticated instruments have to be there, like, because we are not there to obstruct the plant operation. Energy auditor should have all non-intrusive instruments, because the plant has to operate on its own. Like, you have to just have and observe the things and all. We should not affect the output of the plant. We have to do energy audit in a way whereby without affecting the output of the plant, you have to gauge the energy analysis, and then accordingly you have to identify where the industry loses energy. So sophisticated, high-end, non-intrusive equipments have to be there. And of late, some energy auditors are there who are able to hire the energy audit instruments also. And I think there will be some industrial entrepreneurs available on this class. Like, normally we at Anna University or reputed energy audits, we always advise them, if at all you go for energy audits, seek for calibration certificate of equipments. The instruments, whatever the people own, energy auditors and all, it will be quite old. And the value, whatever it tells, it will be having some inherent errors. Just 1 degree centigrade difference will be able to affect the COP of an air conditioning plant by a huge value. Just 1 degree centigrade temperature change will be able to affect the kW per TR. You might even end up in branding that one as an inefficient one, though it might operate well. Because of the inaccuracy of the instrument, you might even identify that this equipment is not operating to the standard, so you can go in for replacement. Wrong diagnosis would happen. So what we normally advise is that once when you go for an energy audit, do insist on calibration certificate of the equipments what the consultant has. Okay. As was informed to you earlier, preliminary energy audit is a walkthrough audit where we go through the plant. We'll be able to arrive at the code that has to be given for doing the energy audits. This code would be arrived by arriving at the expertise of the manpower whom we have to have in the team, and also what are the instruments what that has to be there. This is first one. Second is the number of days what it will take for us to have the whole study done. This will also reveal the attitude of the industry. There are some industries who will do the energy audit just for the sake of compliance. If the kVA demand is 500 kVA or more, mandatory energy audit has to be done. Likewise, there will be some norms like. So based on the norm, some industry would be doing just for the sake of complying. So their attitude towards energy audit will be different. There will be some industries who will be calling us repeatedly. TVS, for example, we do repeat audits for them. Like, if we do it for this year, 2 years afterwards, they'll be again asking us to come and inspect their plant, whereby we do an analysis of their plant. Accordingly, we'll be able to identify where they'll be able to save on the energy aspects. Like, so the preliminary energy audit will give us these informations. Apart from this, we'll also be able to tell what will be the percentage of savings that they can have it on the energy, how much monetary savings that they will be able to achieve, and our code will be based on those things. This is first one. Having preliminary audit done, having understood the scope for doing the study, then based on the scope, the industry may ask you to do detailed energy audit. This is a comprehensive study. This requires the people plus the instrument. You have to analyze the equipments that is available in the industry. A comprehensive analysis has to be done. Accordingly, you have to identify in an industry, you will be having air conditioners, we'll be having motors, we'll be having pumps, we'll be having blowers or fans, we'll be having air compressors, we'll be having boilers. All things will be there. You have to analyze the performance of all these components in the whole plant. You have to identify the one which is having higher amount of energy for the output. Then you have to tell what things that has to be done so that it will become efficient. As a result, the specific energy consumption per product becomes lower. Okay, this is called as detailed energy audit, and comprehensive study would be done. Having done this, there will be some industries which will ask you to focus on one specific utility. They'll be asking you to do one specific utility. Example, Vigaland at Kerala, we have done an audit for them. They were very first we have done this audit, they were happy. Then we have done this audit, they were indeed happy, and they were able to implement all those things and all. After having seen these things and all, they were asking us to do specific energy audit on pumps alone. It's an amusement park. They were having more amount of water rides. So the whole amusement park was having approximately 100 plus pumps. Like, we were able to do the energy audit for all the pumps, and then accordingly they were very happy because they were able to save a lot. They were able to save a lot. Like, so based on the interest of the industry, they will even ask you to do the audit on a specific component also. Even this audit also, it will be done. Like, so these are the three broad ways through which we can carry out the energy audit. Preliminary energy audit, first to find out the scope. Detailed, where you have to do the whole study in-house, like. Then specific energy audit, whereby you will be going in for the component wise. These things I have explained to you, all these things are not. These are the broad steps which we normally follow in an energy audit. First one, we plan. As I told you, what is the manpower that we have to have? What are the instruments what we have? And what is the attitude of the people that who are there on the industry? Based on that one, we will be able to plan. Data collection. This is an Herculean task. I repeat, this is an Herculean task. You have to prove to the industry that because of energy audit, you were able to save on energy. But for proving, you need to have the historical data. See, kilowatt hour per ton of cement, it will be available for that year. But you have to take for the past 3 years so that you will be able to have the average value. Only then the industry would be able to accept, yes, of course, this is true. So much kilowatt hour I'll be able to make for every ton. This is understood. So for fixing that baseline, data collection is mandate. You have to take the EB pattern for the past 3 years. By revealing or by understanding the EB bill, you will be able to identify various things. Some revelations also will be there. Example, whether they've exceeded their contract demand. This is case 1. If the contract demand is becoming more, then that indicates that the load scheduling has to be done. And probably if you see the contract demand for the whole year in a day, for the whole year from Jan to December, the contract demand might vary like this also. You have to check this one with the output. If the output of the industry is constant like this, then it indicates that the same quantity output is able to match with this lower amount of kVA also. So then that becomes a case whereby demand side management has to be done. So data collection has to be done. Data analysis also has to be done. These two I'll be able to tell with an example. It becomes much easier. Once when you do these analysis, you can fix on the area where the energy audit has to be done. Then you have to identify the options through which they'll be able to do energy savings. After identifying the measures, you have to carry out techno-economic feasibility analysis. I'll give you an excellent example for this one. Last, how to implement the proposal that has been identified. So with this, I stop because this is the time. Still there are 97 out of 83. Still there are 14 more slides. I'll be able to cover all those slides afterwards. Probably like this, whenever we have some time, accordingly, we'll be able to have things done. Like, is there any doubt for anyone?
Sir?
Yeah, please, sir.
Yes, sir. Sir, when you're told, when we're discussing about the steps involved in energy audit, like in the data collection part, say if
Yeah.
you are going to a old plant and if you don't have the name details of any of the pumps or motors, and they're asking, the customer is asking us to do an audit on that one, how do we proceed with that aspect, sir?
Without nameplate data, at least the HP of the motor would be available, sir.
Okay, okay, sir. Okay.
Okay,
Only on
so-
the motor side, at least we can do that one.
See, for gauging the effectiveness of an equipment, nameplate information has to be available. Only with the nameplate information, we'll be able to have these analysis done. If nameplate information isn't available, at least the HP of the motor has to be available. Only then we'll be able to see if the motor is rewound, then the amount of power what it draws would be higher. Or the motor would have been identified. See, again, there are different analysis on the motors itself, like motor efficiency. If at all you see, if you plot the graph, the efficiency of motor, the efficiency of the motor graph will be like this approximately. At approximately 80% loading of the motor, the efficiency attains peak like, and it will be almost stagnant for some almost 95% load wise. So this is the typical loading pattern in which the whole motor has to be loaded. If you operate the motor at an part load, the motor, though, see, as okay, I think I wouldn't have informed about this one. 1 minute, please. Hello, sir. Sir. Good morning, sir. Yes, sir. Okay, sir. In over half an hour, sir, I'll be there, sir. Right, sir. Okay, sir. Okay, sir. Okay, sir. Yes, sir. Thank you. Yes, sir. Sir, if online class, sir, no, half an hour, I'll be there, sir. Okay. Yeah. See, one basic thing that we people have to understand and appreciate, all utility will be designed to operate at its highest efficiency level. No equipment, no OEM will make any component to operate at a poor efficiency. This is what we people have to understand. No OEM will make an equipment to operate at a degraded efficiency. All OEMs would be making a product that will be able to give the highest operating efficiency. But only one thing, we have to apply at the range in which it is employed for. If you choose a motor, an high capacity motor for an lower load, then you will be operating the motor at part load. Automatically, your efficiency would be lower. This is efficient, this is load. This leads to inefficient operation. But actually, the same motor, if it is loaded to a higher level, it will be operating at an highest possible efficiency. So ultimately, we have to choose the load and then accordingly have it done. If the motor nameplate information isn't available, then at least the rating, at least the HP of the motor has to be available. Then we have to do the energy analysis. We have to see how much amount of power it draws. Only then we'll be able to tell whether the motor is overloaded or not. Only when overloading or underloading is there, we'll be able to go for this efficiency study. If the loading is appropriate, then majority of the motors would be operating effectively or efficiently.
Thank you, sir. Thank you very much, sir.
Yes, sir. Fine, sir. Any other doubts, please? Shyam? Any
Yes, sir.
instructions?
No, sir. Only one information to participants, those who are joining to the meeting. So please enter your name, then join. Okay. So as per the name what you have given in the ATL, so the same way you can join here. So because some of them have mentioned as only guest. So that's it, sir. Thank you very much, sir.
Thank you, Shyam.
Thank you, sir.
We will
And,
join
yes,
by 11:30, right?
11:30, sir. So the next session with next speaker will join, will resume at 11:30. So please join on time and submit your feedback form for the session 7A and 7B. Thank you.